All right. So good evening, everyone. Welcome to day 8 of our sessions on generative AI and agentic AI. So I hope you were clear on some of the concepts, which we have discussed yesterday. Few, 4 concepts we have discovered. Sorry, we have discovered. Sorry, we have discussed. You know, of NLP on generative AI. So let us continue our journey of understanding a few things, right? So let me share my screen. Okay, 30. All right. Fine. So let us continue. The next concept is named entity recognition or recognition, NER, right? So with the concepts of tokenization, stemming, lemmatization, parts of speech tagging, right? So in that process, the next concept is the named entity recognition. So yesterday, a small brief intro about this named entity recognition I've actually told you, right? So this is a model where it actually identifies the places entities, right? So how or what kind of entities this will actually identify, right? So it identifies person, right? People, okay? So it also identifies the organization, right? And also the location, and it also identifies the dates, right? Time, right? And money, right? Because sometimes what happens is, the number of amount plays a very important role, or sometimes percentage, right? Product, right? So events also which have happened in history, or which are happening now. So one, everything plays a very important role, right? So that is why this named entity recognition model is actually used. Now let us see some real world examples where these are practically applied when using on, or when applied in generative AI. So the first example is the e-commerce platforms. Is something, we can take up an example on iPhone, right? So I bought the iPhone 14 from Amazon from for $999 last week, or almost $1,000 last week. Now the tags here, because we have seen what is tokenization, right? So tokenization is basically giving tokens to each word, a unique number to each word, right? So here what is happening is, right, we automatically, or anyway we do the tokenization part, then the stemming part or lemmatization part, then we also apply the parts of speech tagging to identify the unique words, and to make the words authentic, right? And it follows the dictionary words, right? It doesn't randomly pick some words where it is difficult to build a model. So it doesn't happen like that. So now this also adds up to that 4 models or 4 kinds of concepts, where this will help to understand that what is the important thing here. For example, in this line, if you see, iPhone 14 is important because it is a product, right? And the price is also important, right? And from where it has been brought, because Amazon is an organization. We have seen in the here, no? So person, organization, dates, times, money, percent, everything plays a very important role. So here iPhone 14, right? Amazon, right? And the amount as well is very important, right? So how much price that particular mobile has been bought. And also the key thing is also the dates, right? Here it is last week. For example, when it has been bought, from that day, right, to the previous, from that it will count last week, Okay, so that is in where the date is also very important. So the use cases here is to extracting the product names, brands, prices, all these aspects. So next example is travel booking platforms. So book a flight from New York to Paris on August 10th. So here you have there are a few things which tags will be given. Here the you know booking a flight is very important here, and the places are very important. Here New York to Paris or New York and Paris plays a very important role, and also the date, which is August 10th. So here the use cases automatically extracts the source, destination, and the travel dates from the queries. So next is healthcare and medical reports. So patient was prescribed with 10 grams of one particular medicine by a hospital. Here the hospital name, right? The doctor's name because it's a person, right? The organization, which is some kind of hospital, which whatever it might be, and also the drug. Okay, here it is a drug or a quantity, all right? It's a product, correct? So extracting the drug names, doctors, dosages from the clinical records. So next is news summarization. So here, as we all know that ChatGPT 5 is coming, or GPT 5 is being launched by OpenAI. So it is coming, when it will come into public, that we don't know, but it has been launched, I would say, on March 2025. So here organization name is there, the product is there, right? And the platform is there, or the city, I would say, which is San Francisco. And the date when it is launched, it is March. We don't have a specific date, but we have the month and the year. So automate event tracking and entity profiling is what the use case is. So next is legal document processing. So the agreement was signed between Apple and the government of India. So here again, we have the organizations which are Apple Incorporated and the government of India. So identify involved organizations in the legal contracts. So this is what about the NER. Now, before going into the practical part, let us also see the one-hot encoding. So together, let us see the NER as well as one-hot encoding in action in Python. Okay. So what is one-hot encoding, right? So one-hot encoding is nothing but converting the categorical variables into numerical values, right? So if it is a numerical value directly, right, it is not an issue. We can use the continuous variable methods to actually calculate or build a model. But the problem comes when it is a categorical variable. So that is in where we use the one-hot encoding technique to basically convert the words or categorical variables into numerical numbers. So that is with zeros, ones, and twos, and so on. So now let us see one example of how this one-hot encoding actually works in the real time. So the first thing is applying a sentiment analysis. I love this product, right? Now we all know that identifying or giving tokens to each individual word, that we have already seen in yesterday's session. So how tokenization actually we have seen in the day before session, right? So giving tokens to each word, right? And we have also used stop words, right? So stop words are also removed, which doesn't add much of meaning, is the and, right, for, right? And all these things, all the stop words also, we have removed those also. So that also we have seen in practical in action. So here what will happen is it will start giving words. For example, here to identify the sentiment analysis, the words here are basically to identify the sentiment, we want to use the word love, right? So here, if you want to predict a positive sentiment or to identify a positive sentiment, you have to encode this with 1. So basically, we start giving with 0 and 1. So a matrix will be formed to identify this. Okay, so this also we will see in practical. So you'll be having a better understanding as well. Okay. Next is spam detection in emails. Okay. So here, claim your free price now. Okay. So by identifying each word, right, and creating it as a vector, and by this, what will happen? It will, segregate into each different vector for spam classification. So next is document classification. So text from different topics like the sports, tech, politics, right? And one hot vectors help represent these words. Okay, so goal, sports, algorithm, tech, and election, this politics. Okay, so before going into bag of words, first let us see the practical part. Okay, so that will take more time. So let me go to that aspect. Just give me a minute, I'll share my screen. So first let us see named entity recognition, and then let us see the one hot encoding in action. Okay, so after that, we'll go to the bag of words. So let me share my Jupyter. Sorry, we are going with collab now. I'll share my collab. Give me a minute. Okay. So let me. Okay. So first we'll go with the named entity relation and recognition. Then we'll go with the one hot encoding. Then bag of words and n-grams. Okay. Right. First, let us see the named entity recognition. So the first thing for named entity recognition, to understand what is this, the most important thing is to understand the concept of spacey here. So how we have, okay, uh, importing the necessary. Okay. So here, what we are using is, instead of NLTK, we are using the spacey. Okay. So spacey is a kind of library like NLTK. Okay. What I'll do is, I'll just put this text. I just wanted to put one text so that it will be easy for you to understand. Okay, yeah, I was taking this text for you to understand. Okay, so this will be easy for you. Now see here. So this spacey library, instead of putting this and putting the necessary libraries, I'll put this. Okay, so easy to understand. This is what I was searching for a line for you to make you to understand in a better way. So spacey is basically a natural language processing library. Okay, so don't get confused with NLTK and NLP. Okay, so NLP is a broader concept for generative AI, and NLTK is a library which is used for applying stop words, right? Tokenization, stemming, lemmatization, and all those things. So in the same way, for this named entity recognition, we are using the library which is spacey. Okay. Now, this one model we have to download. Okay. So this is a standard model which is actually used for or to make your page to use the spacey. So the model which needs to be downloaded is en underscore core underscore web underscore sm. Okay, this is a standard function which it's actually a model which is for English. Okay, here you can see en indicates the English part. Okay, so this model you have to import into your page if we want to use the spacey library. Now here I have given a small text. Okay, and in this small text what I have given, right? So here I have given about Apple. It's planning to invest a $5 billion in India by 2025. The announcement was made by Tim Cook in San Francisco on Monday. Now if you see how this is going to actually apply this named entity recognition is, you can see in the output part that it is able to identify that Apple Inc. is an organization, right? Just like I have shown you in the example, right, in the PPT. So for 5 billion, it is showing that it is money. Okay, that is the magic of using this named entity recognition. Okay, so it will be able to classify what is money, what is place, what is organization, what is date, what is person, and so on. By classifying this, what will happen is it will be, or it is going to find easy, right, to build a model. And when we actually ask the model to generate something, it will be in a better position to generate something whatever is required for us. So a part of bigger picture of entire generative AI, this named entity recognition is one of the small concepts which lead up in generating content for us, what we are using in the generative AI. Okay, so this is where I've just mentioned about this so that it will be easy for you. So it's a widely used NLP concept which can have the task like tokenization, parts of speech tagging, and named entity recognition. Okay, this parts of speech tagging tokenization also can be done in the NLTK library also. Okay, it can also be done in NLTK. You can also do it inside spacey. I think a couple of sessions before, one person was asking, so spacey is a bit more fast compared to NLTK. Yeah, it's absolutely right. But I will never rule out NLTK because it is one of the standard libraries for natural language processing, especially when you are going to use inside generative AI. So you cannot leave something which is very important, right? So this is what the whole picture is. So I'll just run this so that to show you again. Okay. So this is the aspect. Now going down, right? Here there is one one aspect. Just a minute. I'll just put here one thing. One more line I will add. This is basically a pre-trained model. So that is one thing I just wanted to ask. Sorry, add. And one more line. Okay. So because I'll be sharing this file with you now, so it will be easy for you to understand. Okay. So SM here you can see that this EN is for English. Okay. And this SM is basically for a small model. Okay. So that is why it is a small model. And we also have big, medium, and large models as well. Okay. Fine. So I think this should be fine. And this one we are processing. And in this function also, I would like to add here, this is just a print function. What I want to add is this ent.text here. Let me add here only so that it will not be a confusion. Okay. Okay. Here I'm adding ent.text is basically the actual entity. Here I have given now ent.text, right? So this is basically relating to the actual entity. Okay, that means whatever we have given. Okay, and here one more I wanted to add is ent.label. Okay, here I have given the function C, ent.label underscore. Correct. So this actually gives the type of entity. Okay. So this actually gives the type of entity. Okay. So I'm just adding here in comments because it will help you as well. Okay. So for you to understand things. And next one is one important one is also there. The spacey dot explain. This is one more thing I just wanted to add. So this spacey dot explain, which is entity dot label underscore. This is basically a human readable explanation. Okay. So here you can see the explanation part. That this first one is the entity.text part, which is the actual entity, which is inside the text. Okay. And the second part, what you are seeing here is the label. It's a type of entity. Okay. That's why clearly I have mentioned here. Okay. So the third one is the, it actually explains the explanation part, human readable explanation. That means you can see that this is an organization like companies, agencies, institutes. So it is actually helping you to understand here also. The output itself is, giving you in an easier way. Correct, no? So that you need not, uh, you know, worry that what it is. Okay. So yeah, this is the one I just wanted to add. Okay. So a lot of comments for you to explain. Okay. Sorry, to understand. Now let us go to the next part. Yeah, this is one of my favorite parts. So here, if you see, oh, okay. So here, if you see one text, what we have given, this is about this text is basically about Tim Cook investing in India. So for that actual text, what we are actually doing is we are visualizing that what is the key things. Okay, what are the important things in that particular entity. So this render function will actually help you see. It is showing anyway. That's good. See, render actually displays what is important. Okay, and it actually tries to identify by a certain colors. That is what this function basically is about. Okay, so Spacey is a library, and it will show module, but don't worry too much. I already told you, uh, for library sometimes it shows as module. That is actually big bummer. I don't know why they show like that. NLTK is actually a library. Okay, even Spacey is also a library. It's not a module. Okay, this displacey, this is actually a module. Okay, see here you can see Spacey's built-in visualization suite for dependencies and named entities. In that you have this displacey. Okay, this render is a function actually. Now here what it will highlight is it will highlight the important things inside the text. See, it is giving you a certain colors. Okay, so it is actually giving you a certain colors to identify. Okay, so it is actually identifying what are the key areas inside that particular text. Okay, now let us this one anyway I have ran. I'll just run it again and show you. Okay, so let us go to the next part. Okay, so this here I've taken a bigger text. Okay, I have not done differently. Okay, we have one something new also in this. Okay, I'll get to that. Here it's just what we have done here. It's not at all different. Okay, the same comments you can use it to put it here also. So text, label, explain everything the same only I've used. Okay, so you can put the same things. Okay, okay, I'll just paste it here. Okay, so it will help you. Fine now, because I've used the same entity.text, label, and explain. Because same thing, it's a standard one. No, why I want to change something which is very standard. Okay. So now if I run this again, I'll get this. Now it will show that in this you have dates, right? So for, I think somewhere I've given March 14th. Huh. So March 14, 2023, it identified that it is a date. Okay. So it has identified that it is a date, right? Microsoft is an organization, correct? And OpenAI is also an organization. So Microsoft on March 14, 2023, Microsoft announced a partnership with OpenAI to integrate ChatGPT 4 into its Bing search engine. This announcement was made at a tech summit in Seattle, where CEO Satya Nadella emphasized the importance of responsible AI development. Meanwhile, Google is working on its own AI models to compete with OpenAI advancements. The US government has allocated 2 billion in funding for AI research in universities like MIT and Stanford. So this is the text, or I would say news. Correct, no? So it's basically a news, right? And we are trying to apply or identify what is important. Uh, you know, what are the important features by using this named entity recognition. Okay, so I think you're fine with this. I ran it again also. Yeah, you can just check this later. Okay, the same one here. Okay, the same one for what I have given. Okay, I have used it there. So anyway, I have ran there. I just didn't give it here, but here also you can give. Okay, so spacey input displacing. So here you can see that what are the important things, right? They are highlighted. Okay, fine now. So this also I think you would have understood, because the same thing what we have given here, the same thing only. Here it's just for a smaller text compared to what we have given here. This is for a bigger text. Okay. First, usually I show like that. Let's go with a smaller text to understand the concept. Then let's go with a bigger text. Okay, that is my way of making you to understand. Okay. So processing, let's say processing the text with spacing. Okay. So this is also done. Rendering. Okay. And let us go to the next one. Okay, which is counting the number of dates. Okay. So for this, for counting the number of dates, okay, we have a particular function for a counter function. I think we have used it before also. Yesterday itself, I think we have used. So anyway, I think you're not new for that function, I think. Correct? Because we have already used. So here you can see that this particular function, what it does is, what is repeating multiple times. For example, here you can see that dates are repeating, dates are only once. Organization 8 times, right? Person 2 times, right? There are two kinds of people, or persons being repeated in the. I think here we have two people. I think Satya Nadella and who's the other person? I don't see anybody. No, definitely there are two people, person, Satya Nadella and Binge. It has taken as fictional. Oh my god. Okay, that is what I'm thinking. Only Satya Nadella has been there. Who is this other person I have been thinking? Okay, so that is one error which this has picked, I would say. Correct? No, because this binge is not a person, this is a search. So it is saying it's including the fictional. How can you say it's a fictional? I don't think so. Okay, no, this is an error. Okay. Yeah. So this is one error where we got. Okay, it's saying including fictional. So next is country, states, and all. So we have three, and money. I think only one. I think $2 million or something money was there. Yeah. So that was the counter, okay, which we had using in the collections. Okay, collections is actually a module. Okay, collections is a module, and counter is also a counter is basically a function inside this collections module. Collections is not a library. Okay, yeah, because for everything it is showing module, and some of them I'm saying that they are not modules, they are libraries. So probably you might be, getting confused. So that is why what I do is I just mention here what are libraries and what is, module, so that it is easy for you to understand. Okay, so Spacey is a library. Okay, even if you Google it also, it will show you that Spacey is a library. Spacey is not a module. Okay, so NLTK is again a library, it's not a module. Okay, so let us go to the next important function. Okay, so yeah, this will take a bit of time to train because this is basically uh, a model. I'll show you. Here, what I'm doing is I'm using one of the important concepts, right? Not just the basics. We are supposed to be, or we have to also understand the advanced concepts what are being implemented as well. So one of the important concepts which are being implemented is the hugging face. Uh, you know, Hugging face inside the concept or inside the framework of transformers. Okay, so here we are using the transformers pipeline. Okay, so pipeline is basically a function. Okay, here you can see, and this transformers is a module. Okay, so it's not showing anything. Okay, so what I'm doing is here, what I'm doing is I have given a particular sentence here, right? So Tesla CEO Elon Musk visited Berlin on Monday to meet with officials about the new gigafactory. Meanwhile, Apple Inc. Incorporated is what Inc is basically. I think you guys know it. So meanwhile, Apple Inc. announced its new headquarters in Austin, Texas, and plans to invent 1 billion. The US government, in collaboration with NASA, is also planning space missions in 2025. So this is the sentence. Now, what is the greatness of using this hugging face transformer basically in named entity recognition is it will give you the probability, or you would say not probability. Uh, yeah, it is actually a probability only, but it will say score. Okay, so in transformers language, it will say as score. Okay, but yeah, it is basically a probability. So it will identify that what is the probability that this is actually 100% correct in its, classification. Okay, now let us see how much well it is classifying itself. Okay, so here you can see that let us go with the 100% probability things. Okay, so let us see the scores of 1. So you would say NASA, it is classifying NASA as an organization, and it is saying that it has classified 100% correctly. So I think you will also agree with me that NASA is an organization. So its own classification score is correct, or score is correct. So US is a location, absolutely correct. Then Texas is also a location, correct. Then Austin is also a location, correct. Apple Incorporated or Apple Inc. is also, it's an organization, that is correct. GigaFa. Now the tricky part. Now it is saying GigaFa is an organization, but it is not sure that it is an organization. It is only 75% sure. This is the magic of using a transformer. Now here, you have seen in live that it is classifying Binge as a person. This is a normal spacey library which is actually used. Okay, this is a transformer. We have already discussed, no, transformers are more powerful, right? This transformer technology is actually invented by Google. Okay, so this is what is powering the generative AI tools kind of right now. So we are in the second generation transformers. Okay, So Hugging Face is one of the models inside the transformers. Now, here, when we have built this transformer architecture, we can see that this GigaFA, it is telling that it has only 75% sure. Let us see what is this first GigaFA. That is what the problem is. It is Gigafactory. Okay. So this Gigafactory, somewhere it has messed up. This BERT tokenizer. See here, this is actually, so when you say transformers, it is using this BERT tokenizer. Okay. So that actually happens. Okay. So I'll just put it here also so that you will understand. Okay. Okay, nice classification. Yeah. So because BERT is basically a, BERT is a classifier. That also we have actually seen. Correct? No. So here what it is doing is it is classifying that this GigaFA, that is the problem. It is not able to identify that Gigafactory. Okay. Yeah. So that is why it was uncertain 25%. Okay. 75% it was sure that it is an organization. Okay. Right. And actually it is correct. Okay. It's an organization only. Now let us move to the next one. So Berlin is a location. Fine. Here it has not probably able to divide. Probably Elon Musk, if it is one word, let us check after that. Probably that might, if I am putting Elon Musk into one word, it is predicting that Elon Musk is an organization. This is the problem. Understood? No. Here, see, when I just change, okay, it is showing, let us divide this and check what it will check. We'll see. It is, the probability has gone down. See, if I divide giga and factory. Okay. So whatever you are giving, the model is actually building tokenizer. Correct now? So Elon Musk, if we put separately only, it is able to classify that Elon Musk is a person. And since it is not 100% certain, it is giving a probability score of 95% and 99%. Got it? No? And here Tesla, it is predicting as a organization, and that also it has a bit of doubt, so it is only giving 98% accuracy. Okay, so this is the advantage of using this BERT tokenizer. BERT tokenizer is a classifier. Okay, so this is what about the named entity recognition. Now what we will do is we will go to the next concept. Okay. It's not going. Okay, thank God. Okay, so named entity organization is done, right? And the next one now is one hot encoding. Okay, so I think you can see this one hot encoding. Let's check whether you're able to see the screen. One hot encoding. Yeah, fine. It's absolutely fine. Okay. Now, so we have seen this, tokenizer, stemming, lemmatization, stop words, right? And parts of speech tagging, and we have also seen name entity recognition, right? So we have seen very important concepts which lead up to generative AI. Now, and we have also used the concept of transformers as well. Correct? Now let us try and understand this one hot encoding. Okay. So now if you see one hot encoding, let us first do with normal machine learning. Okay. So for normal machine learning, we give one hot encoder. Okay. This normal machine learning will be inside sklearn or scikit-learn. Okay. Now we are actually giving one sentence, okay, and we are giving a vocabulary, okay. Now we are applying the one hot encoder function. I think it will show, I guess. It's not showing. Okay, fine. So this one hot encoder will give, for example, you have given I, right? So love data. Okay. So now it will try to encode zeros and ones. This is just with the basic machine learning. Okay. So this is how also we give. Now here, if you see, just go down, I'll show you page. Okay. Just wanted to show you. Okay. So here I've not mentioned with this spacey or something. With the this one re I've mentioned. Okay. Fine. Only transform function. Okay. So yeah, fine. This only I mentioned with the one hot, and I just mentioned with the I would say basic machine learning. Okay. So you can also apply the advanced part also. Okay. So here I've just mentioned like that only. Let me run this. Okay. Let me run all this. Okay. It's connecting to Python. Just please wait. Ah. Oh, it's all good now. Okay. So let us see how it is actually encoding. Let us see one more example. Now, here we have given corpus, which is a sentence, right? So I love data science, I love AI, science loves data. Okay. So once I have given that, I have used this is a standard syntax again, right? This is from sklearn, right? So here also we have given C. sklearn.preprocessing, import the one hot encoder. Okay. The same thing here, we will import, and since the output has to give in an array, we are using numpy as np. Okay. So this is because the output here in one hot encoder, this gives as an array. Okay. So that is why for array outputs, we have to give the numpy or numpy. Okay. Now here in this particular sentence, we are asking it to define the vocabulary. Okay. So here we are applying as tokens. Okay. And now what will happen? It will divide as, it will only give the important words like AI, data, I, love, loves, science. Okay. So here, apart from that, everything else is basically repeated. Okay. It will not give multiple times because you just have asked to give the vocabulary part only. Okay. So next is creating mapping. Okay. So the next thing is basically creating mapping here, word to index mapping. Okay. So what will happen is that a particular word is, or a particular word will be given, and it will manually map, right, which kind of mapping it needs. Okay. So here what they have done is, just for example, what I have mentioned here is in this complete vocabulary, right? So in this complete corpus, okay. So here for this vocabulary as an output, I have given that what is the encoding for the word data. Okay. So whatever it has encoded for the word data, it is giving as an output. Okay. So if I change, right, for example, okay, so what I'll do is I'll just take and insert one line down. Okay. Okay. The same thing I'll take here. What I'll do is what words we have? Love we have, correct? No? So you can see the difference in output. Okay. So if you have an error, you can also try this in Collab. Okay. Oh, here also I didn't change. Yeah. Yes. That's why it's coming this error. It will fix anyway. Yeah. So you can just give this also. It will help you. Okay. This I don't want it. Just give me a minute. Oh, as I have all these things, huh? Just give me. I This is the problem of using Gemini also. That's why it's very important only. I don't, I use Gemini because what it will do is it will keep on, adding things which we don't want also. So it is again difficult to, fix that. Okay, we'll see this later anyway. Okay. Oh, sorry. Anyway, I have given here. Yes. Sorry, please. Okay. Yeah, what I'll do is run it all again. Just run it me because I've added, it has added a few things. Be careful when you're using, uh, this Gemini inside, okay, Google Colab. Yeah, it is sometimes helpful in adding, helping you with the fixing of the code, but sometimes it will create a mess also for you. Um, Yeah. Okay. So this with the data we have seen, and for the other ones also I have encoded here actually. Okay. So for the other words, for love, date, see for anyway for data you can see the same thing. What here it is there, you can see this as an output. For love you are getting this, and for science you are getting this. Okay. For I you are getting this as an output. Okay. Now going down with one hot encoding again, right? So one more kind of words, one more kind of encoding you will actually get. So it's the same thing, okay? Till here it's the same. Now, if you change the text, right? And you know about the tokenization, correct? No? So tokenization is not new, okay? Right? So here we are applying the tokenization. So it is giving the tokens here, you can see the words, okay? In this particular sentence. Now, next, what we will do is one more example is applying the unique vocabulary. Okay. So this unique vocabulary is where it will identify how many words are actually there. Okay. So it is indexing C. When you run the output, it will index to each output. So it is started with and with 0, application 1, assistants 2, like that it is giving numbers to each word. So it will go on till 19 because it starts with 0, no? So 0 to 19 will be 20. Okay. So next example is with one hot encoding. Here for the vocabulary or for the words what we have given in the corpus, here we can encode. Okay. So for and, for applications, for assistants, chatbots, and enables. Okay. So this one hot encoding to view, there is no much of use for us, okay, as a person, but this encoding will help the transformers and the models to properly identify and build a model on the words. Okay, since you have, I have to also explain what is one hot encoding. I'm explaining you this, but as a normal person, if you see, what will you do with this array? Correct? No, you can't do anything. But for the model, it is useful. How it can actually build. So let us, just because you have to understand that what will happen first of all. Okay, whether you are able to use it or not, that's a different story. Because the model uses it, but we are not using as a, for example, here named entity. Oh, we can identify. But here, what is the use to see the 0 1s 0 1s? not that much of use for us, but for the model it is useful because this is a part of generative AI. It is very important for me to take up this aspect as well. Okay, so the same thing here I have applied. Okay, probably I can uh, huh, stop here for this concept. Okay. So now what we will do is what we can do is this named entity. Just give me a minute. Okay. Just a minute. Anyway, I'm sharing with the. Okay. Yesterday's also I've shared it. This also I'll share. Yeah. Okay. So if you have any questions, you can just ask me. Okay. For named entity recognition and one hot encoding I've shared. Okay. So if you have any questions, please you can ask me. So I think if you don't have any questions, we can start with bag of words, right? So bag of words and n-grams is what I am supposed to explain. That's what I thought so. We will see. So based on the now bag of words, anyways, n-grams we will cover. If you have any questions, you can just ping me. Yes, yes, Ashwita. If you have, you just can just put it in the chat. So one hot encoding, I would say, don't break your head too much. Uh, just it is important for the model to build in such a way for each word. So that is why we do that. So named entity recognition is very, very important, right? So anyway, I'm taking up the important concepts only. So bag of words and n-grams we will discuss. They are also very, very important. So if you just ask, if you have any questions, just ping me. Okay, then if you have any questions, you can just ping me in the chat. We'll go for a short break. Okay. So during the break also you can ping because you might think that sometimes suddenly you'll not get, but over a period of 5-10 minutes you might get. So just ping me in the chat if you have any questions. Okay. So if you don't have any, okay, if I don't see any questions after the break, I'll just continue with the concepts which I'm supposed to be explaining. Okay.
అవునులే. ఆ!
Okay, no doubts. So great. So I think it's going fine. Okay, so let me go to the concepts then. Let me explain. Okay, right. So before going into the practical part of bag of bag of words and n-grams, okay. So we'll see together what is bag of words and what is n-grams, okay, and then we will see the practical part, okay, because these two are like a bit of together concepts, so it is easy for you to understand together, okay. So that is what I would say, right? So now let us see what is bag of words. Okay, so bag of words is basically a simple method or a simple, function, I would say, to convert text into numerical vectors. So just now you have seen one hot encoding, right? So this ignores the grammar, word order, and the context, and it will just try to identify the word frequency and it will try to convert into vectors. So that is the main concept behind using the bag of words. Now let us see examples of what is how to use this bag of word. Okay. So let's say your vocabulary is I love data science. And you have a sentence, I love data science and I love learning. Okay. So after removing the stop words and reducing the vocabulary, okay. So I love data science learning. Okay. Here, what will happen is I love data science is there and the stop word, right? Already I is repeated, love is also repeated, right? So how the bag of vectors will be identifying is word frequency count. So you can see how the vector will be actually formed. Here I comes two times, right? You can see here. Love comes two times in the actual sentence. And I think that's it. Correct? So only these two are coming two times. And data is coming once. And science is coming once. And learning is coming once. Okay. So this is how the vector will be formed. So now the vector will be 2, 2, 1, 1, 1. Okay. So this table shows you how the vector will be actually formed. Now, the real world examples for identifying or using this bag of words concept, you want a free money now. You want free money now. Now, to identify the spam in this text, in this email, it will identify the words one, free, money, and now. Okay. So classifier learns to associate high counts of certain words with spam. Okay. So next is product review sentiment. So great product works well and fast. Okay. So bag of words, what it captures? Sentimental words like the great, fast, and well. So these words pattern help a model to predict what is a positive sentiment or a negative sentiment. Next is the topic modeling in news articles. So, articles like, politics, election, government, and vote. And for sports, just for example, I've taken a few things. So, how the bag of words will cluster the documents based on what kind of news article it is. Next, for using the document or for identifying document similarity. Okay. So, converting each resume into a word frequency vector. Then measuring cosine similarity to find the best match. Okay. So cosine similarity is a technique actually to find the similarity between words. Okay. Next is search engines and information retrieval. So machine learning course. So bag of words identifies that the vector with the document vectors, right? And returns the highest scoring matches. Okay. So we will see anyway this bag of vectors in action and practical. When you see the practical part, your understanding will be, much more better. So that's why only just two, three slides, four slides on the concept I've just mentioned. Now, let us go to the next one, which is n-grams. Okay. Now, what is n-grams? Let us try and understand. Okay. So basically, n-grams are a sequence of words or characters which are classified together. Okay. So which are classified together. Now, here, the important words, if they are classified together, it is easy for the model to classify that there is a correlation among those two words. Okay. So now where these n-grams is used. Okay. So it is used for predictive text input, spelling correction, plagiarism, machine translations, right? And sentiment analysis, speech recognition. For all these concepts, you can use the n-grams. So we will also see n-grams in action for a better understanding. The real world examples we have, particularly we use bigrams and trigrams. Okay, bigrams are nothing but word with, you know, two words which are together. For example, when you search in Google, right, there is an autocomplete feature. Okay, so autocomplete feature, one of the functions or methods what that autocomplete uses is the concept of n-grams. Okay, so that is why I told every concept is what we are doing is useful for generative AI. Okay, and a part of generative AI, right? Now, let us see how to make. When you type how to make, the autocomplete feature will try to show a few things. For example, like the make coffee, make pasta, make a website. Okay, so just a few suggestions I have put. Okay, so here if you see when it is saying make coffee, okay, make and coffee are coming together because it's a bigram. Okay, when a model is built, they have been classified together. So it is showing make coffee, make pasta. Sir, make a website, it is three words. No, no, a is a stop word. No, so a is not considered. That is why I told stop words first. Or else when you have go into, there is one more model for this n-grams. Okay, if time permits, we will see today or we will see in tomorrow's session. So we have one more concept called, TDI, IDF. Okay, so that is useful for classification for documents and, so that is very important. That is actually a continuation for n-grams. That also we will see. Now, I think now with this example of bigram prediction, you would have understood how actually the text or things actually work. So text predictions in mobile keyboards, I am. If you type, right, it is going to suggest you a trigram model, which is I am going, I am fine, I am sorry. Now, spelling correction. If someone types THIER, the model may compare it against the bigrams like there, right? Their house, their car, and suggesting there. Okay, it will identify that it could have been this. Maybe it is a spelling correction error. Now, chatbots and voice assistants, book me a flight. Trigram model based models understand this as a common sequence and fetch relevant intent. Next is speech recognition. Audio to text conversion benefits from n-gram probabilities to decide between recognizing the speech versus wreck a nice beach. Okay. Then text summarization and sentiment analysis. So bigram like not good gives a negative sentiment, which single word good is a unigram would miss. Okay. Now, in a final conclusion, n-grams are basically an essential building blocks for many NLP tasks. They model local word dependencies and are widely used in the real world applications like the autocomplete, spell check, machine translation, and much more. All these concepts are and what we use in a real day-to-day life in generative AI. Okay. So before going into TF, IDF, okay, term frequency and inverse document frequency, let us first understand the practical part of bag of words and n-grams. Practical is there no. we have to understand the practical also, not the theoretical text only. Okay, so let us do that. Let me share my screen. Collab. Okay, collab. Yes. Okay. First, we will see the bag of words. Okay. Then first we'll see the bag of words, and then we'll go with the n-grams. Okay. Fine. Right. So now let us see what is bag of words. Right. We have seen the concept, but we have to see it in action. Okay. So there are a few things again which I want to add. Okay. So the first important thing is the count vectorizer. Okay. So I just wanted to add here. Okay. Which will make your understanding much more easy. Oh, this became too big sentence. Huh? Okay. So let me then. Okay. We'll do one thing. We'll cut it here. Okay. So it will be easy for you to see. Okay. Yeah. Just for a quick understanding for you guys, I just mentioned. So here we are using a particular function called as count vectorizer. Okay. So this count vectorizer is inside the sklearn library, which is the scikit-learn library. So this, I would say here again, this sklearn is nothing but a library. Okay, it will show module, but don't worry. Okay, so if you want, I can just mention here also. Sklearn is a library. Okay, so it will be easy for you. And this feature extraction is actually a module. Okay, it's a module. And count vectorizer is a function. Actually, anyway, I have mentioned at the top, but I'm just mentioning it here also. It's a function. Okay, now it will be clear for you. Got it now? So this is basically a scikit-learn. Okay. So what I'll do is I'll just put this in the bracket also. It'll be easy for you to understand. Okay. So the library name is scikit-learn. Okay. And the library name is scikit-learn. Okay. And sklearn is what the name which is used to use it in the Python. Okay. And here you can see that feature extraction is basically a module and count vectorizer is a function. Now, what is this count? See, the definition, what it is telling is it actually tokenizes, right, a collection of text documents and builds a vocabulary of all unique words, then counts the frequency of each word in every document. Okay. Now, here I have given a sample corpus. Okay. Let us say corpus. Okay. So let us say corpus with multiple sentences. Okay. So I love machine learning. I love data science. So I love machine learning and data science. Machine learning is fun and exciting. Data science includes machine learning. Python is great for data analysis. Okay. Now we have already discussed about this count vectorizer. Okay. So this count vectorizer. Okay. Now what I'll do is, yeah, even this one also, I just wanted to put because a few people might get what is corpus doubt. Okay, so it's a list of string where each string is a sentence or document. So that is what we say it as corpus. Okay, yeah, I'm adding what is very important for you to understand as well. Okay, yeah, so I think this should be fine. Now, here if you see, we have something called as count vectorizer. Okay, so I'll just put one more comment here. Okay. So what it will do is, already I have told here where it is. It will tokenize. Okay, it will tokenize the unique words in the vocabulary. Okay, the same goes here. It's also, the comment of mine is also the same. So it will tokenize the text, remove the punctuation, lowercase the words, and build the vocabulary. These many things this count vectorizer is actually doing. That is why it is a very, 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 very important function. Okay. Now, once that is done, there is a thing called as fit. Okay. Now, fit.transform, there is one couple of things which I wanted, to put. Okay. So that it will be easy for you to understand. Now see properly. This fit function will actually fit. Okay. So what is this fit? This is basically learning the vocabulary from the corpus. Okay. So it is like training, right? Or it is building or learning from the corpus. Corpus is nothing but the sentence, what or sentences, or a group of strings or a list of strings, what we have given. It is basically a group of strings for the compiler. For us, it looks a sentence, but the compiler doesn't know that. It's just a group of strings. Strings is nothing but a text data. Okay. So this fit will actually fit or learn right from the vocabulary. Now the next thing is the transform. So transform is nothing but it transforms each sentence, right, or word into a vector. Okay, that is why we use the function fit underscore transform. Okay, so that is the main. Here the function is very small, but our comments are very huge. Yeah. So anyway, no problem. We just have to, the important thing. Okay. Now there is one more comment I want to put to show you. So here I'll just put this also. Okay, for better understanding, because these are advanced concepts. Okay, so this will give you a better understanding. Okay, now to convert the array for display. Okay, so here we are using x and y, and this x object is basically a sparse matrix. Here you can see as bag of words, it is giving a matrix. Okay, for that we are giving this x. Okay, and this toArray is a function which is using or which is making the function x, converting it to an array. Okay, so it is basically converting into a 2D numpy array. Okay, so that the output can be easily printed. Now, and we are, I think that's it. So now this getting the vocabulary also, I just wanted to put one comment for this also. Okay. So yeah. So for this bag of words also, here we are getting the features name, which is the vocabulary. Okay. So what this will do is this will return the list of all the unique words in the vector. Now, if you see in the entire sentence, if you give this vectorizer getting the vectorizer dot get underscore feature underscore names underscore out, it's a very standard syntax. What this will do is it will only give you the unique words. That is very, very, very important what we want to get. So the vocabulary basically should be of unique words. Okay. So now if you see, there is no word which is repeating. Okay. So it's all unique words. Got it now? So this is just printing the result. Okay. So let us run it again because I've added so many comments. Okay. So yeah, the functions are small, less, and the comments are more. Okay, but this will help you to understand, in a better way. Now, in a simple context, the next I'm using here is just converting it into an arrays. This is just using some pandas. Okay, so I just because even using pandas we can do that. So I just wanted to show you that as well. But we are going to use this bigger functions only because these are more, I would say, more impactful and more useful functions. Okay, I think okay, yeah, it's posted attendance. Okay, great. So this one is done, and let us go to the next one. Yes. Now let me take a bigger one. Okay. Here I have used the exact same functions. Here what I have used. Okay. I've not complicated anything so that it will be difficult for you. So I've taken the same functions, and here what I have done is I've taken a bigger text. Okay. So what I have done is, real world corpus like a reviews. So natural language processing is a fascinating field of AI. NLP enables machine to understand, interpret, and generate human language. Applications include machine translation, speech recognition, and chatbots. Text classification is a core task in NLP, useful for spam detection and sentiment analysis. Modern NLP uses the deep learning models like the transformers and BERT for language understanding. Okay, so this is the text. And here, the first thing what we have done, we have used the count vector, and stop words we have included the English, and we have fitted and transformed. So already you have seen here comments anyway I've added. You can use these comments. Okay, again I'm not putting. Okay, and you can actually check that you are converting it to an array. Okay, and then you are getting the vocabulary. Okay, so you're getting the words which are unique, and you are printing it to a data frame. Okay, so you can just check what we have done from before. It's the same thing what we have actually given. Okay, just the, I don't think anything change I have done. Only just I've made it to a bigger text. Okay, yeah. So you can just check whether something different I have done. Only just thing I've given is, instead of just giving as an output as a unique words, I have converted into a, I would say, a matrix. Okay, or a, usually we'll get in a matrix form or a array form, but here what I have done is I have converted into a data frame form. Okay, so like a table. Data frame is nothing but a table. Okay, so we are getting inside the form of a table. Okay. Now let us go to the next thing. Okay. Here I have applied one particular function here, which is the size and words. So here I am printing the vocabulary size. Okay. So vocabulary size is basically 39. Okay, you can see 39 columns here. Correct now? So it is giving 39. Obviously, because one column is one word, right? And here the vocabulary words also we are printing. Okay, so you are getting as an output. Okay, now what I am doing is, next thing is including the bigrams. Okay, so I would actually want to add a few things. I think some questions, I guess. Okay, no, sir has posted attendance. Okay, fine. So I want to add a certain comments here. What I'll do is, so for vectorizer underscore bigram. Okay, so that is the function I have taken. The first one is I have applied the stop words here. Okay, anyway, you are familiar with the count vectorizer. So stop words, anyway, I have applied English. Okay, that you already know. So this ngram what I'll do is I'll just put that comment also because you need to understand that. Just a minute. Just put it and you'll be able to figure it out. This will actually give that you want a 1 gram or a 2 gram, or you can say unigram and a bigram. Okay, that you have to mention. It is very, very important. Huh. Now, so that is for this line. So what I'll do is I give a graph. Okay, so that this is for this, so it will be easily understood for you. So this vectorizer underscore bigram is a variable what I have taken. And here I have used the count vectorizer function, which you already are familiar with. And the stop words here is the stop words the stop words concept, which you already know. Okay, so it's not nothing new. Now, the next thing is the n-gram range. So if you give 1, 2, so you want the range maximum from 1 gram. There is no 0 gram. So it is 1 gram to 2 grams. So you can also use the 3 grams, which is trigrams also. Okay, so here I'm giving 1, 2, so it will give a maximum of 1 gram and 2 grams, or you can say unigram or bigram. Okay, now the next part is building a model, or you can say transforming. Okay, so I have a bit of comment to add for that. What I'll do is for x gram, I'll just put the comments here only. Okay, so it will be easy for you to understand. In one line only I'll put. Okay. Okay, or if you want, I'll change it. Probably make it like this only. That it will be easy for you to understand. Okay. Now, for this function, I'm putting comment. Here, you're say giving the vectorizer. Okay. And you're asking it to learn with the bigram, what you have given here. Vectorizer underscore bigram. Okay, the same thing we have used here. Okay. Now, you're saying fit underscore transform for the corpus. Okay. So here you already know fit will learn, right? And transform will transform the matrix or the words into building a model. Okay. So this will help in returning you the sparse matrix or the matrix form. Okay. Next is using the data frame. Okay. So what we will do is we'll put a comment here. Okay, because I want you to understand in an easier way. Okay, this should be enough. So this basically, we have already seen this to array conversion. This basically converts into an array. Okay, here you can see. Okay, and this name underscore out is what will actually give the unique words. Okay, for the n-grams. Yeah. And the next one is basically printing. Okay, I think this is fine. So this line, this will be sufficient to understand. Okay, so this will actually including the bigrams. For the BOW model. Okay, so BOW is nothing but the bag of words. Okay, you can put it here also if you don't. Okay, so bag of words model. Okay, yeah. So this should help you to understand. I'm running it again. Okay, so you'll get the output without any error. Okay, so this is what about the applying of bigrams in the. Okay. So this part is done, and let us go to the next one, which is n-grams. Okay. Now, by this time, you have a bit of understanding of what is n-grams. So you can figure it out that what are the things which we need. And there are a few things which you can see. For example, like this tokenizer, this function you have already seen. This is not a new function. Okay, so text I have taken first. Let us go with the small text. Okay, so I love natural language processing. I love learning natural language processing. So the new thing is the old thing what you can see is importing the NLTK and word tokenized. Okay, so I'll do like this. It'll be easy for you to understand. Always this should be at the top. Okay, text should be down. Okay, now it should. It doesn't matter, but still, that is the proper way of implementing. So you can see that the new function here is ngrams. This will be in the utility. I think it will show here. I'm not sure. Wait, I'll just select this and check. Or I just showing util only. It's actually a utility function. Okay. So in that utility function, you have this ngrams. Okay. So n indicate whether it is a 1 gram, 2 gram, 3 gram, or any kind of grams. Now, downloading the required tokenizer. So you already are aware of this punct. Correct? No, I'm not going again into the you know. Now here we have given the sentence and we are asking to generate as a bigram or as a trigram. Okay. So if we run this, we'll get the bigram I and love, love and learning, learning and natural, natural and language, language and processing. Now that is bigram, two words in one. The next is the trigrams. So I love learning, three words now. Love, learning and natural, learning natural and language, natural language and processing. So this is three words now together. Okay, this is what it does. Okay, so fine. Now let us go to the next method. Right, this is just by using a pure Python. Okay, so we are not we are not applying this. What we will do is remove this. This will make it 3. Generated trigrams. Okay, and this is generating bigram. Okay, now we run this, we'll get bigram and trigram. See carefully. Okay, just changed. This is a simple method also. Okay, this is just by using a Python. So here we are not using NLTK, any utilities, just a basic Python for generating the bigrams and the trigrams. Okay, so this is also one easier way which you can actually try. Okay, so you can try this as well. And put tokenizing manually. Okay. Now let us go to the next method, which is the third method. So this is basically done using, okay, this is basically done using the count vectorized. Okay, so this is basically a machine learning approach of creating a count vector. I can say grams, okay, bigrams or trigrams. Okay, so basically n-grams, right? So here you are familiar with this count vectorizer. So this is not a new one, and this fit underscore transform is also something which you have already seen. Okay, so let us run this. Yeah. So it is generating a bigram. Okay. Now let us go to the processing. Okay. Let us try it on a bigger text. Okay. Now, that's why I mentioned here n-grams on bigger text. Okay, because the words are more, the generation will be more. Correct? No? Now, here we have started with I could say the first one is importing the NLTK library. Then the second thing is importing of n-grams, or I would say the utility function, or sorry, utility module. Next is the tokenize, which is tokenized module for word tokenize. Then we have the corpus module for importing the stop words. And then we have the, we are using this counter function. So counter, you are also familiar with that. And next is the matplotlib, which is used for data visualization for the words. Now, the resources is so downloading required resources. Okay. And here we are just running it, so just the output will not be happening because it's only downloading the resources and we have just given the text. Okay, so natural language processing is a field of artificial intelligence that focuses on interaction between humans and computers using natural language. With the rise of machine learning and deep learning, NLP has become more powerful, allowing machines to understand, interpret, and generate human language. So common applications include chatbots, machine translation, sentiment analysis, and speech recognition. So this is what the text is about. Now let us go to the next thing, which is pre-processing the text. So for pre-processing, you know how to pre-process. The most important thing is to apply the stop words and punctuation. Okay. So, things like comma and all, not required for analysis, right? So removing that, stop words also we are removing, like the words like the, and, on, everything we are removing. Okay, so we are processing it and we are running it, so we will get the cleaned tokens, okay, by the method of tokenization. Okay, so next is generating the bigrams and trigrams. Okay, so here we are generating just by using the function n-grams, and we have given 2, so which will generate the bigrams, 3 will generate the trigrams. Okay, let me remove this sample bigrams. I would like this word here. We just put bigrams. Okay, now let us go to the fourth step, which is counting the frequency of that bigrams. Okay, now here you can see that the counter function, here it is used, what we have given there. So this counter function will count. So as we already know, and we have already used it, it's not a new function, we are using for the first time. So here it will count, okay, and here it will count. Natural and language is together, it is coming 2 times, okay, and language and processing is 1. So only this natural and language is coming multiple times, okay, and the other things are coming one once, and these are the top 10. Okay, and then this is what actually we have counted. So next is the visualizing. Okay, so this visualizing will give you the number of counts, okay, that how many grams are there. Here you can see by this counter function itself, right? Natural language is coming twice in the bigram. Okay, so that is what you can visualize here. Okay, I'm just visualizing the bigrams. You can try it for the trigrams also. Okay, so here the most commonly repeated one is natural language. Natural language is not one word, don't get confused. These are 2 words. Processing NLP field, those are two separate words. Natural and language is repeating twice or coming twice as a bigram. The others are coming only once. That you can visualize. Okay, so this is about the bigrams. So why this is basically used in a model for generative AI is it will club the words together. Okay, so by clubbing the words together, it will help you. It will basically help you to understand, right, that which words are coming together. Okay, so that is the main importance, especially when it comes to using of bigrams. Okay, so which words are coming together and which are have more probability of actually that we will there are other models that how it will calculate probability in identifying which curve, how much probability is there that which words actually come together, which has more probability. So based on the model, which kind of words you are giving in the search, like the example, like the autocomplete, which words have more probability by the text what you have given, that words will appear together, whether it's a bigram, trigram, or fourgram. So this is how autocomplete feature actually works. Okay, so it's a um, serious application of n-grams and bag of words and all. So this is what is the concept. So if you have 5 minutes, we have. If you have any questions, please you can ask me. Okay. So I'll share this named entity one hot encoding I've shared correct now. So what I'll do is I'll be sharing this tag of words also along with that n-grams also. Okay. So I've shared all the 4 files. It will be uploaded in your LMS as well. Okay. I'll share with Amar sir as well. He'll upload it. So named entity recognition, one hot encoding, bag of words. I've shared it in the chat. Okay, n-grams you can download it from here. I think you can download it. Yeah. Don't try to open it. It will not open. I told you, you have to open it in Jupyter Notebook, import, or you can put it in your Google Drive and directly open it Google Colab. Okay. So there are 2 ways of opening the file. So don't double click on your local computer and try to open it. Okay, please do that and tell it it's not opening. Yeah. So if you have any questions, please you can tell me or you can ask me. Okay. N-grams, bag of words is done. So yeah. So this TF IDF will start tomorrow. After that, we have word to vector function also, which is very important, which is actually started by Google. And let us see a few deep learning concepts which are linked directly to generative AI. Okay, like the using of using ANN and RNN functions, how these are used in BERT and GPT, which are the concepts of directly transformers and all. So word embeddings and all we will see. Okay, so which are very important. Okay. Yeah. So another 3 minutes, guys, please, if you have any questions or if you're very clear, great. I'm very happy because, that's why I'm taking, in every concept, what I'm doing is I'm taking simple examples of, to make you to understand. I'm not taking very complicated ones also because a few might be new to the, these kinds of concepts as well. So if you're aware of it, great. But if you're not aware of it, it will be bit of tough. So I'm just taking simple examples and adding comments also so that it will be easy for you when you go through to figure it out. So I'll just wait till 9. If you have any questions, please you can ask me another couple of minutes. So you can mark your attendance as well. Sir has shared it in the group. So in the chat, you can mark your attendance and you can give your valuable feedback, which will be helpful for us to, enhance or make modifications in the kind of experience we can give you. So your feedback is very important, and marking the attendance is also very important for you to get the certificate as well. So please kindly you can do that. It will help you. So I'll wait till 9, okay? And then if you're not having anything, probably we can wind it up. Okay.
Profiles.
Yeah, okay, sir.
Any more profiles, Pulakeshu? Any more profiles are under evaluation?
Sir, Amar sir, you can take over.
Yeah, sure, sir. If we're done, then we'll see you tomorrow.
Sure. Done, sir.
Thank you.
Yeah.